now we're looking at target 4.3. I can apply the counting principle by identifying independent and dependent events to identify the number of outcomes. So, our fundamental counting principle states, if there are m ways to do one thing, and n ways to do another, the number of ways to do both is m times n. Alright, example 1. Suppose you have 3 shirts, 4 pairs of pants, and 2 pairs of socks. How many different outfits can you make? Okay, so this one actually has, 3 different things. Our fundamental counting principle, the definition, we only do 2, but we can extend that. If you have more events, you just keep multiplying. So I have 3 shirts times 4 pants times 2 socks. Okay, so 3 times 4 times 2. Well, 3 times 4 is 12, times 2 is 24. So that's 24 outfits. Okay, so nice and simple. Okay, same type of thing for that doesn't want to move. Example 2, there are 7 stairways to the second floor with 4 emergency fire exits. How many different routes out of the building are there? So in this one, same type of thing, we have 7 stairs times 4 exits. So between those two, 7 times 4 is 28. We have 28 routes. So then we're looking at independent or dependent events. And what independent or dependent events are is, if an event is independent, then the first event does not affect is an action, affect the number of outcomes, this number, for the second event. If 2 events are dependent events, then the first event does affect of outcomes for the second event. Okay, and we'll see some examples of this, but for example, so if I have 7 stairs, when I get to the bottom of the stairs, I can still get to all 4 exits, that would be independent, right? It doesn't matter which staircase I could take, I can still get to all the exits. If I take one staircase and I can only then get to 3 of the exits, one of the exits is like blocked off if I choose a specific staircase, that would be dependent, right? Because my number here would change, right? So let's look at some other examples. Geometric events are independent or dependent. Then determine how many outcomes there are. Okay. So a pair of shoes come in 7 sizes and 3 colors. I can choose 7 sizes. I'm going to choose my size. I have 7 to choose from. It doesn't matter which size I choose. All the colors are available for every size. So there's 21 options, right? So the 2 we did at the beginning were also independent events in the way they were asked. Looking at B, there are 10 dogs in a dog show, and you have to choose the winner and the runner-up. So when I go to choose my first dog, right, there's 10 dogs I'm going to choose from. But now that I've chosen a dog as the winner, that dog doesn't go back in the pile of dogs I have to choose from. They're probably not in a pile, but you know what I mean. All right, so when I go to choose my runner-up, there's only 9 dogs remaining. That number has changed. Okay? And so now there's 90 options. Okay? So that's the difference. So this one is independent, and this one is dependent. Jack has a bag of jelly beans. There are 6 green, 4 blue, 5 red, and 1 yellow. I don't know why there's a comma after that 5. Jack picks 3 jelly beans, replacing them each time. Maybe he doesn't get the color he likes. Okay. So how many jelly beans are there? 6, 10, 15. There's 16 jelly beans. So he goes to choose a jelly bean. 16. He puts it back and goes to choose another. That's another 16. He puts it back. There's still 16 jelly beans in my bag. Okay. So 16 times 16 times 16 equals 4,096. All my numbers stay the same. It never changed, so this is independent. Jack has a bag of jelly beans. There are 6 green, 4 blue, 5 red, and 1 yellow bean. Jack picks 3 jelly beans and then eats them. Okay? So when he chooses his first jelly bean, he eats it. And then he chooses his second one and he eats it. And then, right, he chooses his third one. So after every time, right, there's 1 less jelly bean. Now my numbers have changed. So I have 16 times 15 times 14. And now I only have 3,360 options. So these are dependent. So it's very important to know if it's independent or dependent, because that 3,360, sorry. Because that does change your total, right? These numbers here represent the total number of options, and our probability is out of the total. So these would be very different probabilities. Okay? I believe that is it. I'll see you guys tomorrow.